Alright, so in this problem, I have 5 to the power of x is equal to 0. So, I obviously want to find the value of x here. So for my solution, well, I'm going to first start by, let's start by trying out values of x. So if I have 5 to the power of 1, for example, this is equal to 5, right? If I have 5 to the power of, let's do 1 less than 1, 0. Well, any number to the power of 0 is 1. If I have 5 to the power of negative 1, this is going to be 1/5. If I have 5 to the power of negative 2, this is going to be 1 over 25. Let's say I have 5 to the power of negative 10. This is going to be 1 over 5 to the power of 10. So you see, as the exponent keeps on decreasing and decreasing and decreasing, well, it's approaching infinity, right? But will it ever reach infinity? Well, let's see if we can even find a value of x that makes this equal to 0. So, the first step I'm going to do is take the log on both sides. So I have log 5 to the power of x is equal to log of 0. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x. And I can move x here to the front. So now I have x times log 5 is equal to log 0. Now, if I divide both sides by log 5, these two cancel out, and I get x is equal to log 0 over log 5. Now log 5, this is equal to 0.6990, and log 0, this is actually undefined, meaning I have x is equal to undefined over 0.6990. Well, if something's undefined and you divide it by a number, it's still going to be undefined. So, meaning the value of x is undefined. Alright, so in this problem, I have m to the power of 3 plus m is equal to 350. So the first thing I'm going to do is subtract 350 on both sides. So these two cancel out, and now I have m to the power of 3 plus m minus 350 is equal to 0. Now, m to the power of 3 plus m minus 350, well, I can rewrite 350 here as negative 343 minus 7. So now I have m to the power of 3 minus 347 plus m minus 7 is equal to 0. Well, m to the power of 3 minus 347, this is the same thing as m to the power of 3 minus 7 to the power of 3. And I have this plus m minus 7. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is the same thing as a minus b times a squared plus ab plus b squared. So in this case, a is m and b is 7. So I have m minus 7 times m squared plus 7m plus 7 squared. I have this plus m minus 7 is equal to 0. Now, 7 squared, this is the same thing as 49, so I have m minus 7 times m squared plus 7m plus 49. plus m minus 7 is equal to 0. Now if I factor out m minus 7, I have m minus 7 times m squared plus 7m plus 49 plus 1, which is equal to 50. So this is equal to 0. So now this gives me two equations. I have m minus 7 is equal to 0, and I have m squared plus 7m plus 50 is equal to 0. So m minus 7 equals 0. This is the same thing as m equals 7, so this is already one solution of m. And m squared plus 7m plus 50, you have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the same thing as negative 7 plus or minus the square root of 7 squared, which is 49, minus 4 times a, which is 1, times c, which is 50. And if you notice, this is the same thing as the square root of 49 minus 200, which is going to be a negative number, meaning this won't work, and my only solution is m equals 7. Alright, so in this problem, I have 2 to the power of 24 minus 16. So to solve it, I'm going to first rewrite 2 to the power of 24 here as 2 to the power of 12 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2, that's going to equal 2 to the power of 12 to the power of 2. And I have this minus 16, which is the same thing as 4 to the power of 2. Now if I have something in form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is 2 to the power of 12, and b is 4. So I have 2 to the power of 12 plus 4 times 2 to the power of 12 minus 4. 2 to the power of 12, well, 2 to the power of 10, this is 1024. So 2 to the power of 11, this is going to be double of 1004, which is 2048. Meaning 2 to the power of 12, this is double of 2048, which is 4096. So now I have 4096 plus 4 times 4096 minus 4. Now this is the same thing as 5000 times 4092. Or sorry, this is the same thing as 4100 times 4092, which is the same thing as 4000 plus 100 times 4000 plus 92. So now to solve this, I'm simply going to just distribute. So I have 4000 here. If I distribute, I have 4000 times 4000 plus 4000 times 92 plus, now if I distribute the 100 times 4000 plus 100 times 92. Now 4000 times 4000, that's 4000 squared, plus 4000 times 92. 4000 times 92, that's going to be equal to, 1 second, 368,000 plus 100 times 4,000, that's going to be 400,000 plus 100 times 92, that's 9,200. Now 4,000 squared, that's going to be 16 million. So I have this plus 368,000 plus 400,000 plus 9,200 is 400,000, 9,200. Sorry, 409,200. So now I have 16 million plus 368,000, which is 16,368,000, but I have plus 409,200. So this is going to be 700,000, 720. Sorry, 200. So this is my answer. Alright, so in this video, I'm going to solve the equation x to the power of 2 minus x to the power of 3 is equal to 80. So, to solve this equation, I'm going to first start by subtracting 80 on both sides. So now I get x to the power of 2 minus x to the power of 3 minus 80 is equal to 0. Now from here, I'm going to replace 80, negative 80, I should say, with negative 16 minus 64. Now, I'm going to rewrite this as, I'm going to first rewrite negative 16 as negative 4 squared, and negative 64 as negative 4 to the power of 3. And I'm going to group x squared with negative 4 squared, and x to the power of 3 with negative 4 to the power of 3. So now there's two properties that I'm going to use. And before that, I'm going to write this as x squared minus 4 squared, and I'm going to group this minus x to the power of 3 plus 4 to the power of 3. We put this plus because this negative sign distributes. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And if I have something in the form a to the power of 3 plus b to the power of 3, which is this is equal to a plus b times a squared minus ab plus b squared. So for x squared minus 4 squared, it's going to turn into x plus 4 times x minus 4. I have this minus a to the power of 3 plus b to the power of 3, or in this case, x to the power of 3 plus 4 to the power of 3 is going to turn into x plus 4 times x squared minus 4x plus 16. Now, because both of these terms have x plus 4 in them, I can factor out x plus 4. So I get x plus 4 times x minus 4 minus x squared minus 4x plus 16 is equal to 0. Now from here, this is equal to x plus 4 times x minus 4 minus x squared plus 4x minus 16. I just distribute the negative sign is equal to 0. And let's simplify this even more. I get x plus 4 times negative x squared plus 5x minus 20 is equal to 0. So I get two equations from this. I get x plus 4 equals 0, and negative x squared plus 5x minus 20 is equal to 0. So first, for x plus 4 equals 0, all we have to do is subtract 4 on both sides, and we get x is equal to negative 4. Now, for negative x squared plus 5x minus 20 equals 0, well, first off, we have a negative sign in front of x squared, so I'm actually going to get rid of that by multiplying both sides by negative 1. So I get x squared minus 5x plus 20 is equal to 0. And now, to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 5, and c is 20. So I get x is equal to negative of negative 5 plus or minus the square root of b squared, which is negative 5 squared, which is 25, minus 4 times a, which is 1, times c, which is 20, all over 2a, so 2 times 1. And this is equal to 5 plus or minus the square root of 25 minus 80 over 2, which is equal to 5 plus or minus the square root of negative 55 over 2. Now, this is equal to the square root of 55 times the square root of negative 1 over 2. And the square root of negative 1 is equal to the imaginary number I. So I get 5 plus or minus the square root of 55i over 2. So this is two more solutions to this equation. Thank you for watching. Please make sure to subscribe, leave a like, and share this to any of your friends and family.